This video shows you how we're going to use RidleyIQ to do the transformer design for a 2-switch forward converter. Transformer design is probably the most sophisticated part of what you have to do with magnetics. There are so many considerations. Everything is rolled into RidleyIQ to make it nice and easy for you. So let's get started.
Click on specifications to start your design.
Here's the design. If you watch the previous video, number 7, you'll see how we designed the inductor for this converter. Now we're working on the transformer, so we can look at the currents that we're seeing in this transformer. Primary currents are quite small because we've got a 400 volts input, but you see we have almost 2 amps of primary peak current there. Our waveforms are lots of AC component here, no DC of course, but being a transformer. And secondary waveforms, here we see our 10 to 14 amps for an average of 12 amps on the output for this 19 volt power supply. And the inductor here that's causing the ripple is that 12.7 microhenry inductor that we designed in the previous video. Now let's go look at our transformer design. So if you click on the transformer here, you can see it wants a 7.5 to 1 transformer ratio. That gives us enough voltage on the secondary to work with, make sure we're regulating the output voltage. So that's how the transformer turns ratio is designed. So here is the fundamental component level design of the transformer. And now we're going to dive in and do the detailed component design.
Transformer designer.
And here we are. Let me get rid of some details here for you. So this is our transformer schematic. We see we have a transformer, a magnetizing inductance, primary secondary resistances, and primary secondary turns ratio, of course. So in the past, course attendees and everybody using RidleyWorks has always clicked on this little circuit model going through the numbers in sequence here to choose their core, to choose their winding layouts, do AC resistance, choose their core material, and everything you need to implement the transformer. Of course, that's all still there for you to do it manual and refine it afterwards after RidleyWorks has done its thing. But we've now added RidleyWorks to the mix, which is going to automate that entire process. Quite honestly, when you first come into designing a transformer, there's so many variables and so many things to know. You're going to appreciate what RidleyWorks is doing for you. So under RidleyIQ, we see that, as with the inductor, there are core families to choose from. And I have to say I find myself quite particular to the EPC family of cores. This is a family from TDK that has a very nice long window winding area. And that lets us get low leakage inductance and gives us plenty of room to put in the windings for the transformer and the secondary. Under wire types, we'll start with magnet wire primary, magnet wire secondary. Of course, that's going to need some margin tape to work with as we get into the details. But for now, let's just do it with the magnet wire. And we'll click on RidleyIQ. Notice, by the way, you can see the parameters in this circuit diagram changing as we go through the design. For example, we start out with 8.6 turns, which of course you can't have. So when we click on RidleyIQ,
optimizing transformer with RidleyIQ. Simulating to steady state.
Runs a simulation.
Core selected.
Then it's going to go and select a specific core, EPC 30 in this case. And now the turns have changed, of course, to reflect the new core.
Optimizing transformer primary winding layers.
Now we're looking at the layout of the primary, testing different winding variations.
Optimization complete. Optimizing secondary winding layers. Optimization complete. Transformer design complete.
So there we go.
Transformer loss 2.914 watts.
2.9 watts of loss for a 228 watt converter. That's pretty good. Now, if you look at the details, we click on summary here. And here we see we've got an EPC 30. It's got 28 gauge wire in the primary. It's got 16 gauge wire in the secondary using 2 strands. You don't really want to go much bigger than 16 gauge wire in the secondary. And it comes in with pretty good losses in here. Core loss is 1.16 watts. We could work on that. We could try different materials. There's lots of different variations you could make on this design. Before we do that though, let's look at insulating properties. So let's put a triple insulated wire in the secondary of the transformer, and we'll go through the process again.
Optimizing transformer with RidleyIQ. Simulating to steady state. Core selected.
It's optimizing the primary and the secondary.
Optimizing transformer primary winding layers. Primary optimization complete. Optimizing secondary winding layers. Optimization complete. Transformer design complete. Total transformer loss 3.1486 watts.
Okay, and what we have on the summary page now, this is information that you can give to your manufacturer, and any competent magnetics manufacturer could take this table of results here and give you samples usually quite quickly. Or as we do in our labs, you could wind these yourself. So there's lots of different options here for doing the transformer design. RidleyIQ, RidleyWorks will let you go through those options really fast. You can see how quick this design process is. So this will totally change the way you think about magnetics design, and you'll get really comfortable with your magnetics very quickly, and it's not something to be afraid of anymore.